Hey guys, I am going to go through the 4.3 notes with you here, which are graphing tangent and cotangent functions. And we're also going to work with graphing their translations. So before we do any examples, let's go over the basics together. When we're graphing tangent functions, here is our general form: y equals a tangent b times x. Just like with sine and cosine, a is always our amplitude, which affects how high or how low our graph goes on the y-axis, and b helps us calculate our period. Now, something really important to write down here is the way we calculate the period for a tangent function. When we calculated the period for sine and cosine, it was 2 pi over b. For tangent functions, the period is pi over b. So that's going to be very important for you to remember and to write down. Now, one other thing I want to quickly go through with you is talking about our quadrantal angles and their tangent values. You should have noticed whenever we work with sine and cosine functions, no matter what values we plugged into the function, the outputs were always our quadrantal angles. They were always 0, 2 pi, pi, 3 pi over 2, or pi over 2. When we do tangent functions, whenever we plug any value into x, we're also going to end up with special angles. At 0 degrees, you should remember that the coordinate there on our unit circle is 1, 0. If we find the tangent of that point, we would do 0 divided by 1, sine divided by cosine, which means the tangent at 0 degrees is 0. We also need to talk about the tangent at pi over 4. You should remember on our unit circle at pi over 4, it's the coordinate square root of 2 over 2, square root of 2 over 2, which means the tangent there is 1. At pi over 2, at our 90-degree angle, we have the coordinate 0, 1, which means to find the tangent, it would be 1 divided by 0, which is undefined. We also need to talk about right here, that is 3 pi over 4. That's negative square root of 2 over 2 and positive square root of 2 over 2, which means the tangent there is negative 1. And last but not least, we have pi right there at 180 degrees, and the tangent there is 0. So we're going to keep that in mind as we solve our tangent functions. If we jump over here to cotangent, a and b do the same thing, and our period here is also pi divided by b. And before I move on, I want to quickly review our angles here. We're going to work at 0 degrees. We're going to work at, that should say pi over 4. We'll fix that. This is pi over 4. This is pi over 2. We're also going to work with 3 pi over 4 and pi. And I'm going to quickly go in there and plug in our tangents. The tangent at 0 degrees for, cotangent at 0 degrees is undefined. It is 1 here, 0 there, negative 1 there, and undefined there. That gives us everything we need to then go and do a couple examples. Here we go. All right, here is our first example, y equals tangent of 2x. Just like we did for sine and cosine, I'm going to go through and I am going to find my amplitude. I am going to calculate my period. I'm going to calculate what I need to count by. We do not need to calculate where we're going to start because there are no parentheses. X is not being moved left or right. So our amplitude is always the number in front of the trig function, which is 1. Our period, remember we're in tangent, so it's pi over b. Our b value is 2. And to find what we count by, we always divide by 4, which is the same as multiplying by 1/4, which means we're going to count by pi over 8. And we are ready to now set up our graph. Again, if you want to pause and try this on your own, I would say go ahead and do that. But counting by pi over 8, we start at 0. 0 plus pi over 8 is pi over 8. If we add pi over 8 again, I get 2 pi over 8, which is pi over 4. If I add pi over 8 again, I get 3 pi over 8. And I get 4 pi over 8, which is pi over 2. I've got my 5 points, which means now I am ready to plug in. So if I plug in 0 to my function, we get y equals the tangent of 2 times 0, which means we're calculating the tangent of 0 degrees. If I pop back over to tangent at 0 degrees, the tangent there is 0. So that is my first point, 0, 0. If we plug in pi over 8 next, I'm going to erase this so that I've got some more room to work. If we plug in pi over 8 next, we end up with y equals the tangent of 2 times pi over 8, which is the tangent of, well, 2 pi over 8 reduces to pi over 4. If we look back at our thing at pi over 4, the tangent there is 1. So I'm going to plot a point at 1. If we plug in pi over 4 into our function, we end up with the tangent of 2 pi over 4, which reduces to pi over 2. The tangent at pi over 2 is undefined, which means we're going to draw an asymptote. You should remember from Algebra 1 and Algebra 2, an asymptote is going to look like, in our case, a dotted line that goes vertically when we graph tangent and cotangent functions. Continuing on, if I plug in 3 pi over 8, that multiply it by 2, we get 6 pi over 8. And 6 pi over 8 is going to reduce to 3 pi over 4. The tangent there is -1. And last but not least, plugging in 2 times pi over 2, we get the tangent at pi, which is 0. So now we're ready to graph. And before I do that, I'm going to pop back over here because I'd like to add something into my tangent notes. Anytime you graph a tangent function, you're going to end up with a squiggly line that looks like this. One half of it falls, one half of it rises. It can also go in the opposite direction. One half of it falls, one half of it rises. So if I jump back to my graph, taking a look at my lines here, starting at 0, 0, I see that this point is going and curving up. We always draw our arrows going towards our asymptote, which means on the right-hand side of the asymptote, I want to draw this curve going towards the asymptote. So that's one period of this tangent function. Let's try another example. We're graphing now y equals -3 times the tangent of 1/2 x. Starting this problem the same way we did last time, we're going to calculate our amplitude, we're going to calculate our period, and we're going to calculate what we are counting by on our graph. Again, x is not being moved left or right here, so we don't have to worry about where we're starting. We're going to be starting at x equals 0. Our amplitude here is 3. Remember, amplitude always has to be positive. That negative simply tells me there's going to be a reflection happening. The period here is not 2 pi. Miss Sweeney made a mistake. Our period is for tangent is always pi divided by b. So we've got pi divided by 1/2, which becomes 2 pi. All right. And for our count, remember we always take our period and divide it by 4 or multiply by 1/4, which means we are going to count by pi over 2. I'm going to set up my graph now. We're starting at 0 and we're counting by pi over 2. So we've got 0. If I add pi over 2, I get pi over 2. If I add pi over 2 again, we get 2 pi over 2, which is pi. Then I've got 3 pi over 2, and last but not least is 4 pi over 2, which is 2 pi. Now I am ready to plug my numbers in and go. I'm going to plug in my 0 first, so I'm replacing x with 0. 1/2 times 0 is 0. The tangent at 0, well, let's go back and check. Our tangent at 0 is 0. And then 0 times -3 is 0. So we've still got the point 0, 0. Before I move on, I know that my amplitude is 3, which means the highest this thing is going to go is up 3, and the lowest it's going to go is down 3. If I plug in pi over 2 next, I'm going to take out that 0, and I'm going to plug in pi over 2. That means I'm finding the tangent at pi over 4, which is 1. And 1 times -3 is -3. If we plug in pi is the next thing we need to plug in. Oops. If we plug in pi, we've got the tangent at pi over 2. The tangent at pi over 2 is undefined, which means we need to draw our vertical asymptote. Next, we are going to plug in our 3 pi over 2. So we've got 3 pi over 2, which is the tangent of the tangent of 3 pi over 4, which is -1, and -1 times -3 is +3. And for our last point, plugging in 2 pi into our function, plugging in 2 pi there, we're finding the tangent at pi, which is 0, and 0 times that -3 in the front is 0. Connecting our dots, remember we always draw towards the asymptote. So on the left-hand side, I'm going to curve towards the asymptote. On the right-hand side, we're going to curve towards the asymptote. When you draw these, make sure you are making a curved line, not a straight line. I've done a poor job down here drawing a curved line. IB will take off points if they are not curvy. So make a point to make sure it looks curvy, not a straight line. All right, we've got 2 more examples. I'm going to skip example 4, excuse me. So let's do 2 more. Again, maybe take a minute to pause and see if you can try this one on your own. All right, finding our amplitude, our period, and our count. Our amplitude is 1/2. Our period is pi divided by 2. And our count, we always divide by 4, which is the same as multiplying by 1/4, which means our count is pi over 8. Setting up our graph, again, you might want to pause and try this on your own and then press play and see how you did. Starting at 0 and adding pi over 8 each time, we've got pi over 8, we've got 2 pi over 8, we've got 3 pi over 8, and 4 pi over 8. we've got our 5 points, which means we are ready to plug in and go. Plugging in our 0 for x first. I'm going to do that real quick, plugging in 0. Well, 2 times 0 is 0, and the cotangent at 0, well, if I jump back over here, here's my cotangent at 0, it's undefined, which means at the point 0, 0, we are drawing a vertical asymptote, not horizontal. Next, we plug in pi over 8. If I plug in pi over 8, we get 2 pi over 8, which is pi over 4. Cotangent at pi over 4, if you look back at your graph, is 1. And 1 times 1/2 is 1/2. So I'm going to put a height of 1 here and a -1 here, but then just graph in between at 1/2. If you want to just draw the 1/2 off to the side, that's fine as well. Plugging in pi over 4, we've got 2 times pi over 4, which is pi over 2. Cotangent at pi over 2 is 0, and 0 times 1/2 is 0. If we plug in 3 pi over 8, we get 6 pi over 8, which reduces to 3 pi over 4. The cotangent at 3 pi over 4 is -1, and -1 times the 1/2 in front is -1/2. Plugging in pi over 2, we've got 2 times pi over 2, which is pi. Cotangent at pi is undefined, which means we have another vertical asymptote. Connecting these dots for this one period, remember we curve towards the asymptote, which means on the left we're going to curve up towards that asymptote, and on the right we're going to curve down towards the other asymptote. And let's go to our last example. So this one's kind of gross because you'll notice we have a horizontal shift, and right here we also have a vertical shift. So we're going to be very careful as we set up this problem, finding the amplitude, finding the period, finding what we're going to count by on our graph. We also need to, in this case, figure out where to start because we're no longer starting at 0, 0. Go ahead and pause and see if you can find these 4 things on your own. Our amplitude is always the number in front of the trig function, which means our amplitude here is 1. Our period, this is cotangent, so it's pi divided by b. Our b value is 1, which means the period is just pi. Our count is always the period divided by 4, and we're starting where those parentheses are equal to 0, which means we're going to start at x equals positive pi over 4. As we set up our graph, we want to make sure we get our 5 points to graph one period, so we're starting at pi over 4. That's our starting point. And we get to count by pi over 4. That's going to be easy for us. We've got 2 pi over 4 next, which is pi over 2. 3 pi over 4. 4 pi over 4. And 5 pi over 4. So now I've got my 5 points, and we are ready to plug in and go. So I'm going to erase this x so you can see what I'm going to do to plug in my values. First value I want to plug in is pi over 4. Well, pi over 4 minus pi over 4 is 0, and the cotangent at 0, I'll go check, cotangent at 0 is undefined, which means we are going to have a vertical asymptote at pi over 4. Alright, I'm going to go back in, and this time I am plugging in pi over 2. pi over 2 minus pi over 4 is pi over 4. The cotangent at pi over 4 is 1. So now I'm looking at negative 2 minus 1. Well, that gives me negative 3. So there's my next point. If we plug in 3 pi over 4 next, oops, we get the cotangent of 2 pi over 4, and 2 pi over 4 is the cotangent at pi over 2, which is 0. So now we're looking at negative 2 minus 0, which is just negative 2. If we plug in pi next, we'll plug in pi there next, pi minus pi over 4 is 3 pi over 4. The cotangent at 3 pi over 4 is negative 1. So now we've got negative 2 minus negative 1, which is negative 2 plus 1, which is negative 1. And last but not least, I'm not going to write it out, but if I plug in 5 pi over 4, I'm looking at the cotangent of pi, which is undefined, which means we've got another vertical asymptote there. Again, curving towards the asymptote. On the left, it's going to go down towards the asymptote. On the right, it's going to go up towards the asymptote. And that was our last example. So take a look. Here is our 4.3 homework right there for you. Only 4 problems for you to do. Remember that my answer key is on ManageBack for you. If you need help getting through that homework, I'm also available for tutoring. Go ahead and take a look at the course schedule and information. Good luck. I miss you guys. Have a great rest of your day.